Hi, class. I wanted to record the near pod from Tuesday and Wednesday just in case anyone was absent or if you wanted to kind of just refresh your memory. And so I wanted to put some notes on here for you. So on Tuesday and Wednesday, we talked about angle relationships. Okay, and we had learned some of these the first and second week of school, but then we added on some extra rules. And so let's go over this, okay? So the goal for today is that we're going to use different angle relationships and we're going to write an algebraic expression or an equation so that we could find the unknown angle.
Just a reminder that for today's schedule, our release time is 3:10. We will be releasing and ringing the bell at 3:10 today. Thank you. Have a great afternoon.
Okay, and so our first one that we want to remember is complementary angles. So angles who add up, two angles that add up to be at 90 degrees. And these are complementary. They do not need to be adjacent, meaning they don't have to be connected. In this picture, they are connected, but they do not have to be. So this picture shows adjacent angles because they share a side, but they're also complementary because if you say 55 plus 35, you get 90 degrees. And so DAC and CAB are complementary angles together. Or you might just see the word complement. And so on a test, it might say, what angle is complement of angle DAC? Okay, and that just means which ones are complementary to each other. A good way to remember these, because we also have supplementary angles in a minute, the best way to remember these is C comes before S in the alphabet, and 90 degrees is less than 180. And so the 90 comes first because it's less, and the C comes first in the alphabet. So C and 90 and S and 180. Sometimes that helps because I noticed on a lot of the homework, you guys were accidentally switching supplementary and complementary. And so complementary C is 90 degrees because 90 degrees is less, and C comes first in the alphabet. Okay, maybe that helps a little bit. So the picture here shows 50 degrees and 40 degrees. And so it says two angles whose measures add up to sum of 90 degrees. What are these? And so you have to remember they are complementary, okay? And so we did this in class. All right, and here's a picture of supplementary. So we just talked about that a little bit ago too, is there two angles that add up to 180 degrees. They do not have to be adjacent, but they might. In this picture, they're not adjacent because they're not showing a common side. They're not sharing a common side. And so these two angles are supplementary because they add up to 180 degrees. Now, if they are supplementary and adjacent, they also get a special name called linear pairs. And so if you have adjacent angles and they're sharing a side, right? They're adjacent, and they add up to 180 degrees, they're linear pairs because they're making that line. And so they're a linear pair because the pair is making up a line. Okay, so think of it that way. And a line is 180 degrees. Okay, so question, right? Two angles whose measures have a sum of 180 degrees. What's their relationship? Now be careful. The picture shows one thing, but the description doesn't necessarily say that they're adjacent. And so we usually don't want to just go off the picture on a question. And this is a good rule of thumb for the test because pictures are not always drawn to scale. They're sometimes just there for a visual. And so in this case, this picture shows that they're adjacent, but when the question's actually being read, nowhere does it say it's adjacent. It just says two angles whose measures have a sum of 180 degrees. And so we have to assume that they are not adjacent, or they might be adjacent, or we don't know. And so the only thing we can for sure guarantee is that these are supplementary, okay? If you went just based off the picture, you might have said they were a linear pair. But again, we don't want to always base off the picture because the picture is not always drawn to scale. Our next relationship that we've been talking about is vertical angles. So vertical angles are across from each other. And so when two lines intersect, they create kind of this X, right? And so across from each other, if you look in this picture, we have A and B. And so A and B are vertical angles of each other, and vertical angles are equal. So if A was 45 degrees, then B would also be 45 degrees. And so we have an example of this. So a pair of congruent angles who form by two intersecting lines. You'll see the purple angles are both 130, so they're across from each other. And you'll see the other vertical angles are 50 because they're across from each other. What's also interesting about this picture that's not brought up though, is there's another relationship going on. If you look at just the black and the purple, these are linear pairs. They're two angles who share a common side, so they're adjacent, and they add up to 180. And so right here, we actually have another relationship that wasn't even mentioned. And so you'll notice as we get further on about angles this year, there's going to be multiple relationships that start showing. Okay, we did talk about bisectors a few weeks ago, but I wanted to bring it up again. So a bisector cuts something equally into two pieces. If it's an angle bisector, it is cutting the angle equally into two pieces. And so if I have DAB, then DAB is my big angle. So if you want to take your finger and follow DAB, that's the big angle. If I have a bisector of AC, so AC is a segment bisector, it cut my angle DAB directly in half. So that's why you see that both smaller angles, DAC and CAB, are the same. They're both 35 degrees. Okay, bisector cuts them in half. We already talked about adjacent angles, but here's a picture just in case. So they share a side and they share a vertex. Okay, let's try these questions. In class, they did these alone, but since we're here together, we can do them. That way, if you got them wrong, you can kind of go over them again. So we have two non-overlapping angles that share a common side. So if I look at my options, the only thing that shares a common side and has no other rules in this case would be adjacent angles. Now, linear pairs do share a side, but they also add up to 180, so that wasn't enough information. Okay. Two angles whose measures add up to 180 degrees. Just based on this information, we cannot determine that there's any adjacent angles, so they would not be a linear pair. That's not an option anyway, though, in this case. And so our only option here is supplementary. Supplementary, two angles that add up to 180. Two angles whose measure add up to 90 degrees. So again, 90 degrees, okay, are complementary. Two angles across from one another where the two lines intersect. So again, they're making kind of that X shape, and those are my vertical angles. Vertical angles are also equal to each other. Their measurements are equal. And the last question, it says, what pair of angles is a linear pair? And so you have to kind of look at the picture and you say, okay, a linear pair are two angles that make a line, right? So if I follow my finger, DEG, DEG, and GEB, well, they're next to each other, but they don't make a whole straight line. It's missing a piece. So A would not be the answer. If I look at B, DEG, and BEC. Well, now I'm missing the middle part. Even though it's a small little portion, it still matters, and so it is not creating a full line. So B is not the correct answer. C, DEG, DEG, and GEC. Okay, there we go. Two full angles that make up a line. And so the answer would be C. Just to remind you of complementary angles again. So So now in class, what I had you guys do was I had you write an algebraic expression. So we know these are complementary angles, meaning they add up to be 90 degrees. But now can we write it as an algebraic expression? Okay, and this might be easier right now where you don't need the algebraic expression, but later on you're going to, and so it's good practice to start thinking about it. So in class, we should have went n plus 29 equals 90 degrees. And so to solve for n, I just have to do 90 minus the 29. So again, n plus 29 equals 90. And so we should get 61 degrees. And here's what it looks like as an algebraic expression. Again, you probably did this in your head, but it's good to know that this is how we would set it up, because as we start adding more variables, the setup is really important. Just to remind you what supplementary angles are again. And so let's set up this one. We have two angles that are supplementary. And so let's write out an expression, an algebraic expression would be x plus 66 equals 180 degrees. And so then we would do 180 minus the 66. And so we would learn that 114 would be x. And here's a picture of it. Again, could you have done this in your head? Probably. But knowing how to write the algebraic expression is going to be important, because as I start adding more algebra, knowing how to set it up is going to help you solve those tougher problems. All right, thanks, guys.